Hey guys, welcome back again to another edition in geometry. It's Mr. Anderson here, taking you through. We're in chapter 10 today. Chapter 10, section 4. We're going to talk about inscribed angles. Okay, we've talked about inscribed polygons, I think a couple sections ago, so we're going to talk some more about inscribed angles. Our objectives today, we want to find the measures of inscribed angles and find the measures of angles of inscribed polygons. All right, well, let's start out by going over what is an inscribed angle. Well, an inscribed angle has its vertex on the circle, and its sides are chords of that circle, okay? So this is what it's going to look like here. So this angle here, the vertex goes back to the opposite side, basically, of the circle. What we talked about before were angles that were central angles. Remember, the angle went to right here. So if we went from A to the center and then the center to B, that would be the central angle. And that's what we talked about before. Well, this now we're talking about is an inscribed angle. So this inscribed angle, basically, from this arc AB, goes not to the center, but all the way kind of to the opposite side here. Okay, so the key thing about this is, remember before when we had a central angle, the degree of the central angle was exactly the same as the degree of the arc. Same exact thing. So today, though, with an inscribed angle, the measure of the inscribed angle is 1/2 of the arc. Okay, and so therefore, if let's say, I'm just going to make something up here, if AB, let's say that was 100 degrees. If this was 100 degrees here, that arc of AB, well then angle 1 back here would be 50 degrees. Okay, it would just be half of that. So if you know the arc, then you can just divide by 2 to get the inscribed angle, and if you know the inscribed angle, you know this is twice as much. And it kind of makes sense too. You know, if you think about it, I'm going to try to draw a central angle here. So more or less like that. You remember this 100 degrees would be the same as this angle right here, right? These two would be the same. Central angle would be the same as the arc. And if you look, just even the way these two angles look, this angle 1 over here, that looks smaller, doesn't it, than this one? And so if you can kind of keep that in mind, sometimes people get those confused, but if you keep that in mind, that central angle is exactly the same as this, and the inscribed angle is half that size. Okay, well, let's use it. All right, so we want to find the measure of angle X. We've got some inscribed angles here. So measure of angle X, that's this one right here. So what we want to do is we want to follow this angle and go out to where the, by the way, I didn't mention this here too, but ZW, the arc that's formed there, it's just called the intercepted arc. So we're going to go to the intercepted arc here, which is ZW, and that's 86. Well, if that's 86 degrees, then angle X here would be half of that, so this would be what, 43 degrees. So the measure of angle X would be 43 degrees. Okay, make sense? Likewise, now we're going to try to find the measure of the arc YX. So this is the arc YX out here. That's the intercepted arc. And remember this angle here, so we follow that back to where the angle is. It's inscribed. That's 52 degrees, so that means that out here this would be double, right? And so this would be 104 degrees. Okay, not too bad, right? Just remember half and double depending on which way you're going. Okay, getting a little trickier here, but this is kind of cool. If you have two inscribed angles that intercept the same arc, then the angles are congruent. So think about this. If you just look at this red one here, okay, let's say whatever, AD, I don't know, let's make this 88 degrees, just something different. If AD, if that arc is 88 degrees, well, then you go on this red angle, you go back here, angle B would be what, half of that, right? 44. But notice this blue angle here also goes out to that same arc of AD. It's 88. which is 88. So angle C would be also half of that, or 44. And so if you notice, what this is saying is angle C and angle B are the same. They're going to equal each other. Okay, so even if we don't know what the degrees are, we do know that these two angles have to equal each other because they're both going to be half of that arc. Okay, so let's see how we can do this. Okay, well, let's do this. I'm going to see if I can't have some fun here and go to a highlighter. And so let's first start by, I'm going to start by highlighting this. Okay. So there's, and of course I got to go back to my pen here. So there's the angle R, okay? And so if you notice, angle R here goes out to TQ, the arc TQ. All right. So we don't know specifically what that number is. I think if I do this correctly, I can, how about green? Okay, look at me. And so now here's this angle S I made in green. And so so you notice that green angle goes out also to arc TQ. So we don't know what that is. We don't know what the degree is out there for TQ, but we know that this R will be half of that, and we know that angle S will also be half of that. So therefore, these two angles have to equal each other. So our equation there is just going to be 12x minus 13 will equal 9x plus 2. They have to equal each other. And so to solve that, we just use some algebra. So minus 9x and then plus 13. And so then this is going to be 3x equals 15 divided by 3, x equals 5. Now, I kind of botched that, but I shouldn't have jumped the gun there, because that's not really our final answer, is it? We're trying to find the measure of the angle R, so that means we have to plug it in. So the measure of angle R would equal 12 times 5 minus 13. And so that's going to be what, 60 minus 13? And so that's going to be 47 degrees. And by the way, remember how we could check this? Since that yellow angle is supposed to be the same as the green angle, what if we put 5 in here? 9 times 5 is 45. Plus 2 is 47. Good, checks out. All right, let's do this one more time here. I'm not going to do the highlighting this time, but if you notice, GJH goes to this arc GH, and HIG also goes to the arc HG, and so therefore angle I and angle J have to be the same, right? So we would just take 8x plus 9, make it equal to 10x minus 1 minus 8x plus 1. So we have 2x equals 10 divided by 2. Well, interestingly enough, x also equals 5 here. But again, we're trying to find the measure of angle I, and so let's just plug that in there. The measure of angle I would equal 8 times 5 plus 9. 8 times 5 is 40, plus 9 is 49. And if we want to check ourselves, the other angle should be exactly the same. So 5, put it in here. 10 times 5 is 50. Minus 1 is 49. Excellent. Okay. Inscribed polygons. And in this case, specifically an inscribed, we're going to talk about an inscribed triangle specifically here. An inscribed angle of a triangle intercepts the diameter or a semicircle if the angle is a right angle. So, and this should make sense to with what we were just talking about, and they're talking about angle G here. If this is a 90-degree angle, if this is a 90-degree angle right here, remember that's an inscribed angle, and the intercepted arc would be FH here, right? FJH, which is a straight line. It's a diameter. FH is a diameter, so this would be a semicircle, which is 180 degrees. If this is 180, straight across from it, the inscribed angle would be 90 degrees. So that makes sense. So if, in this case, we're going to deal with a triangle here, but it's that same concept that the inscribed angle is half of the arc there. So let's take a look at an example. Now in this situation, we know that AB is a diameter. So that's a diameter, which means it's 180 degrees, right? And so therefore C, since this is a diameter here, it's an inscribed inscribed triangle. So this C would have to be 90 degrees. Okay, well, so what could I do then to find measure of angle B? Well, think back to triangles. You go, well, how many degrees are in a triangle? There are 180 degrees in a triangle. So therefore, if we just add up angle A, angle B, and 90, we can make that equal 180. So x plus 4 plus 8x minus 4 plus 90 would equal 180. Okay, so going back to our triangle days, combine like terms, I have x and 8x, it looks like will be 9x. And then interestingly enough, I have a positive 4 and a negative 4, so they just cancel. So all I have left here, it looks like, is plus 90 equals 180 minus 90. So 9x equals 90. Divide by 9. It looks like x is 10, but hold on, stop. Don't put a box around it, because we're trying to find the measure of angle B. So again, let's plug it in over here. The measure of angle B would be 8 times 10 minus 4. 8 times 10 is 80, minus 4 is 76. Box it. Okay, and if you wanted to, you could kind of double check this here. If you know that x is 10, plug it in over here. You go 10 plus 4 is 14. And so if you have 14 and 76, that gives you 90, plus another 90 would be 180. So it all works out there if you wanted to check yourself that way. All right, an inscribed quadrilateral now. Okay, so once again, we've got an inscribed polygon, but this time it's a quadrilateral. And so here's the key thing about this. The opposite angles are supplementary. Okay, so the two opposite sides are going to add up to, remember, supplementary means it equals 180. Okay, so the opposite sides are 180. So what that means is here, if you look down here, that L and N are opposite of each other. L and N, these two together will add up to 180, and K and M together will add up to be 180. Okay, so that's kind of the main thing to remember here if it's a quadrilateral. So in this situation here, we have an inscribed quadrilateral. We're going to try to find S, and then we're going to try to find T. Okay, so if we look at this, remember what we just talked about. The key thing to pay attention to here is that the two opposite angles are supplementary. And so if you look at this, you go, well, V is marked as 90 degrees. Well, S, we go, well, together these are supposed to add up to be 180, so that means S would have to be what? Also 90, right? Because 90 plus 90 would be 180. So that's kind of an easy one. Measure of angle S would just be 90. And then to find the measure of angle T, basically these two will have to add up to be 180. So we just do what? 8x plus 4 plus 14x would equal 90. Why did I say 90? Because there was a guy walking by my window and I got distracted. 180. because they're supplementary, remember, 180. All right, so combine like terms. 8x plus 14x is 22x. Minus 4. So we have 22x equals 176, it looks like. Divide by 22. I think I might get my calculator on this one. And so here we've got then, I'm going to try something. Oh, awesome. Look at that. Learning something new every day. 176. Of course, I can't do the divided by, I don't think. Divided by 22. And so that looks like that works out to be x equals 8. Now, though, we're trying to find the measure of angle t, so if x is 8, we just plug it in here. So the measure of angle t is 8 times 8 plus 4. 8 times 8 is 64, plus 4 is 68. And so if we really want to double check ourselves on this one, then we know that this is 68, these are both 90, and then this would be what? 14 times 8. So 14 times 8. So this should be 112, and so we can just do 112 plus 90 plus 90 plus, what did we get for that one? 68. And it comes out to be 360, and so we're looking good. All right, very good. Okay, I think that's it. So, yeah, that is it. Appreciate you being here for section 10.4, and hope to see you again soon in section 10.5. We'll see you next time. Bye.